computer is like a violin. You can imagine it with a beautiful music, but you have to learn how to play it. A quote by Bill Gates. A very good afternoon to the guest of today's program, Dr. Rajkumar Bhuiya, Director Cloud Computing and Distributed System, Clouds Lab, the University of Melbourne, Australia. We have with us a guest from industry, Mr. Dheeraj Modghare, Director of Engineer with Global Logic India, Dr. Manoj Brahme, Head of Information Technology Department, faculty members, and dear students. I, Professor Shubhangi Chaure, welcome you all on the today's Industry Academia interface. Today, there are several examples of cloud computing applications used by both business as well as individuals. Cloud computing is a practice of managing and storing data online servers. It is on-demand access via internet to computing resources, applications, servers, data storage, development tools, networking capabilities, and many more. To know more on this, it is my honor to introduce today's guest, Mr. Dheeraj Modghare. Sir is an MBA in System and IT, and he has done Bachelor's of Engineering in Computer Science and Engineering from Amravati University. Sir is experienced IT professional with around 2 decades of expertise in information technology and specializing in digital transformations, clouds and applications engineering also. Presently, Sir is working as a Director of Engineering with Global Logic India. He worked with various technologies like Java, Python, Agile methodology, program management, technical solutions, architectural and design, digital transformation, digital strategy, cloud native, and agnostic architecture, hybrid and multi-cloud implementations, and many more. Sir is passionate about driving innovations and excellence in technology and solutions for all sort of digital transformations like cloud, telematics, data science, and AI. Sir was previously associated with renowned industries like Birlasoft, Tech Mahindra, Mastercard Inc., KPIT Technologies, Tata Consultancy Services, Cognizant Technology Solutions, Simpax Software Solutions Private Limited. We are privileged to have you, sir. Now, I would like to request Mr. Dheeraj Modghare, sir, to proceed for today's session.
गुड आफ्टरनून ऑल। सबको नींद आ रही है क्या? आना नहीं चाहिए। अच्छा, वन मोर टाइम। गुड आफ्टरनून ऑल। थोड़ा सा और जोर से, ठीक है? ये ऊपर का ये जो सीलिंग है वो हिलना चाहिए, ठीक है? गुड आफ्टरनून ऑल। थैंक यू। अभी नींद नहीं आ रही ना? नहीं आएगी, आई कैन प्रॉमिस दैट टू यू, ठीक है? वी आर गोइंग टू हैव अ जर्नी. We will see what are the technologies that you should learn in 2024, right? And we are not only going to have a session where I'm speaking only, right? And you are listening. We are going to have a very virtual, very video, audio centric presentation. All right. So I hope you all will like it. Excited, guys? अगेन सब सो गए फिर से, ठीक है? मैंने एक्साइटेड गाइस बोला तो सब लड़के हाँ बोलेंगे, गर्ल्स बोला गर्ल्स हाँ बोलेगी. आई नीड टू सी द पावर, ठीक है? एक्साइटेड गाइस? गर्ल्स? ऑसम. ऑल राइट. सो दिस इज माई टॉपिक, top 10 technologies to learn in 2024. All right. All right. So this is about me, guys. This is me. These are my two kids, my mom, my wife, right? I am a leader. I mentor a lot. I work with Global Logic as a director. I have worked with many IT companies. I am a solution architect, Java developer, by nature, and I'm a foodie. I like music. I also like watching Bollywood movies, right? So this is about me. Okay. So why should you think about emerging technologies, right? Why should you think about it? Yeah. Why should one learn about it if they are emerging, right? They are not stable yet. They are emerging. Why should you learn about it? Yeah? So here are some examples. Knowing about them will keep you relevant. You will know that what is going to happen in the upcoming future, right? Like when I studied my engineering, guys, I was studying 8085, 8086 processor. I was studying C, but then my first job was completely on Java, right? You can understand, right? Whatever you learn in very small span of time, you will see that that technology would change, that evolve, right? I start learning Java 17, till the time I finish it, I have Java 22 there, right? It is happening with most of you as well. If you are learning, those who are learning, they know that the technology evolves very fast, right? So to be relevant, you need to understand what is coming in the future for you, right? This is one. Again, if you need to showcase your innovation, your creativity, unless you understand what is something new, how would you pitch for something which is new, something which is innovative? So you need to have an eye on the technologies of future. Those technologies are something that you would like to learn first of all. Why? Because you want to be the pioneer. You don't want to be lagged behind, because someone else is learning that, right? You have to be someone who actually pioneers that technology, right? So innovation, creativity, and for being pioneer, right, within that technology, to grab the opportunities in the market, you need to know these emerging technologies, right? Right, future proof your career. Obviously we talk about it. If you are pioneer about any technology which is upcoming, your future is foolproof, right? You are talking something which is coming to be in the future. It is it is in a stage where it is coming up. If you start learning, till the time it matures, you have enough information about it, right? Then some of the people are, they are entrepreneurs, right? So they would like to explore the area where, why can't they come up with a product on that technology, right? Why can't you create some model, create some tangible benefits out of it, right? And that can you convert that particular technology as a service and then sell for your own benefit, for money, right? So that is something, again, very important aspect, right? And then obviously, we as an engineer, we always have to learn, right? Every day we are learning, every new thing we have to learn, right? Apart from the textual knowledge, we also need to have hands on, right? So we need to evolve, or we need to grow our hands-on mindset and a continuous learning mindset. The day you stop learning in this particular field, you are off grade, you are not relevant, and you will be thrown out, right? I am not telling you, I am not making you fear about the facts, but this is the harsh truth. So it's better that we start developing this mindset every now and then, every day, right? All right. So let's start. This is a preset, right? Why we need to learn these technologies. I'm sure you'll love it. So the first technology that we are going to learn about is quantum computing. And I want you not I want you to read the slogan as well, right? And what is the slogan? The slogan is tomorrow's solutions today, right? So in every era, when you see that today we have our own problem, but tomorrow we will have certain new problems. So how do we encounter that, right? So when COVID happened to the universe, to the earth, right, or to the countries, we were not having any vaccine, right? We were not knowing how the virus would evolve, right? But can you think about a solution where it starts thinking about how the virus will evolve, what will be the medicine which will go with it, what is there a medicine which has a very broad impact so that it covers many variants at once. All that requires too much of processing, because we have different human races, we have different allergies, then we have different health elements, comorbid situation, then medicines, then the environment, the evolution of the virus is itself, it's a very fundamental form of life, so you don't understand that well. All of that is a mathematical problem to solve, and believe me, if we really do that, it is going to take an 5 years to just research about it. If the execution will take that long, right? So, do we have a technology? Can I have a technology which can process a huge amount of data, not with zeros and ones, but with quantum computing? So, quantum entanglement, and there are electrons which are entangled to each other, right? So, can I make use of that electron which can take n number of stages, right? We only have two stages of 0 and 1, or two phases 0 and 1. Can we have a mechanism, right, that can help me solve a particular problem with 10x speed or 100x speed or 1000x speed? And yes, we have it, and that is called as quantum computing. I'm playing a video, very interesting one, please have a look. Play it. Give me 1 minute, guys.
Quantum computing is not just better computing, faster computing. It's a different kind of computing. It's predicted to solve some of the world's most fundamental problems, from inventing new drugs to making brand new materials and creating more precise climate models. It could solve some problems in seconds that would take current supercomputers thousands of years. The technology is in its early stages, but the effort is quickly gaining momentum. So how will quantum computing change the world?
A standard computer might have billions of bits. Each one can be a 1 or a 0, and they're all completely separate from each other. Quantum bits, or qubits, work differently for a couple of reasons that come from quantum mechanics.
Thanks, Jason, but let's not go down that rabbit hole. All you need to know is this.
The theory shows that certain kinds of problems, not all, just some particularly thorny ones, are made much easier when you've got quantum computers. One of those problems is in encryption, the kinds of codes that protect your credit card details online or your messages in WhatsApp or Signal. What got people really interested in making quantum computers was the realization that they could break encryption that was supposed to be too hard to crack because regular computers couldn't crack them. That's the kind of thing that gets the attention of national governments, the ability to crack other countries' encrypted networks. As in the case of artificial intelligence, China says it intends to lead the world in quantum science and has announced plans to open its own national quantum laboratory to open in 2020. America is getting involved too. It intends to create a national quantum initiative. That's because the prize that quantum computing offers, the potential strategic or commercial advantage, is huge. Imagine if you could make minute-to-minute, real-time stock predictions based on data from every trade ever made. Or if you could simply compute the formula for a new fuel or a drug that beats a horrible disease. That's the kind of promise that quantum computing may offer. There are already quantum computers out there, but it's a bit like the situation with regular computers in the 1950s. Big basement-sized things that required a pile of PhDs to operate, and they still weren't very powerful.
Typewriter-like keyboard is the master control, setting out data and instructions on a punched tape, which in turn feeds the electronic computer.
There's a huge effort to make more powerful quantum computers. This used to be the stuff of university physics departments, but you can see the potential when you see who's in the business now. It's big names like Google, Microsoft, IBM. But it's not just about when one day, one company or one lab invents this one computer. It's going to be a bunch of small advances towards the kind that's commercially available, reliable, and can really solve some of these big problems.
Problems that once took the human mind 7 years to solve.
Here's the thing. When we talk about quantum computing, people tend to think of all-singing, all-powerful machine that can run any kind of program. It's called a universal computer. That's still a distant prospect. But in the meantime, there will be smaller machines, more specific purpose, less general purpose. These things are incredibly hard to run. They're held at temperatures lower than that of deep space, in very, very controlled laboratory environments. Even if you could just pick one up off the shelf, you wouldn't. Yes, they're incredibly powerful for some kinds of problems, but they're not going to replace the kind of computer on your desk or in your phone. You don't need quantum powers to edit photos or send emails. In fact, what will probably happen is that a few companies have the best computers, and you can use them on a kind of timeshare basis in the cloud. Or you send off your gnarly quantum problem and just get an answer back. But the kinds of problems that we'll be able to pose, the kinds of answers we'll be able to get, are absolutely unthinkable now. And that's what has governments, industry giants, and plucky startups in on the race.
Okay. So key points that we can take from this is, it is quantum computing is not for general purpose computing. It is for niche problems. So, probably in the future you will see that there will be new research, there will be new, methodologies that will come up, the new infrastructure will come up where the tremendous computing power will be available for each one of you, right? But right now it is, you have seen it is in a large room, it is lots of, cold storage is there. Unless you have that, it would not allow you to have the entanglement, and hence it will not process, right? So right now Delhi dur hai, right? But yes, it is an emerging technology, you should keep an eye. Basically you should understand the fundamental. What is qubits, and you can very well, if you are attending an interview, somebody might ask you, right, what is a qubit, and you should be able to define that. So that's quantum computing for you. All right. So next, all right, next is AR and VR. AR is augmented reality, and VR is virtual reality, right? So again, let us read the slogan: enhancing experience beyond the ordinary, right? You might have seen, if you, let's say if you are buying a furniture on Amazon, or buying a chair or freeze, right? Nowadays what happens is you can see it fitting in your home, right? You can see that, right? Everyone has seen that feature, guys? Yes or no? If you see, or for example, if many of you are wearing specs, right? Like me, right? So if you go to Lenskart, they allow you to have a real time photograph, and they show you how the spec is fitting you, right? Have you seen that feature, guys? Right? So what is that? Augmented reality, right? What is this made for? It is made for you to have a better experience, right? Likewise, there are tremendous uses, like for example, training. So let's say there is a vocational training for someone who can fix a car. And how many cars you have? No car, how many times you will fix it, fix it, break it, right? Not practical. So why can't you have an environment where a person can wear, augmented reality glasses, and he would be trained on a virtual car on how do we fix it? Isn't it practical? He can do that n number of times. He can practice. There is no cost involved, and he can practice anytime. Right? Any problem, anytime he can practice. So it is effective. So let us see a video again.
These days, we spend a lot of time looking at screens. Computers, smartphones, and televisions are a big part of our lives. They're how we get most of our news, use social media, watch movies, and more. Virtual reality and augmented reality are two technologies changing the way we use screens, creating new and exciting interactive experiences. Virtual reality, also known as VR, uses a headset with a built-in screen that displays a virtual environment for you to explore. These headsets use a technology called head tracking, which allows you to look around the environment by simply moving your head. Augmented reality, or AR, is a bit different. Instead of transporting you to a virtual world, it takes digital images and layers them on the real world around you. This is done through the use of either a clear visor or a smartphone. So, with VR, you could explore a world full of dinosaurs. But with AR, you could see those dinosaurs moving through the world around you. Both of these technologies are growing at a rapid pace and being implemented in a variety of different ways. Surgeons are using VR to practice highly technical surgeries before operating. Businesses are using them to give consumers virtual tours of products and locations. There are even apps that can use your smartphone's camera to scan and translate a foreign language in real time. As they continue to grow, VR and AR have the potential to greatly change almost every industry. You'll want to keep an eye on them to see how they might soon affect your job and potentially your everyday life.
Goodwill Community Foundation, creating opportunities for better.
Short but sweet video, right? But again, what are the important points to note? The last feature that was shown, right, where a camera, you can use it to, in a real time, you can see the translation, right? Right. So I have used it. I have went to Canada, and there lots of places they use French. I understand English, but not French, obviously. And the language semantics are very different. So it is not that you can understand what is written, and I could use that feature to actually understand what is telling, and it is very simple. You can just pick your smartphone and see what that particular sign is. Like here it was showing exit, right? That exit is, you are able to see it in real time, that this is the exit sign and you can exit, right? So very important, very small but important, but very intuitive. This can be very useful in medicine, right? In operations, in trainings, in fact, in space technology. All these are very important aspects where you cannot play with the real hardware, the real machinery. You should, think about, if you are writing your paper, if you are writing your research, if you are coding, right? You should think about such scenarios where you can make use of AR and VR. All right. Next technology, please. Biotechnology, right? Again, what is the slogan for biotechnology? Unveiling nature's secrets, healing humanity, right? How many of you are wearing a smartwatch? Raise your hands. Quite a bit, right? At least 5-10% people, they are using it, right? Now, what is biotechnology, right? It is not us only when we say bio. Bio is everywhere, all right? From the tree, plants, from the weather, environment, fish, birds, anything, everything, right? What we eat, our food, everything is biotechnology, right? So, what happens in biotechnology is you make use of complex processing to improve a particular aspect of a living organism or a living thing, right? For example, if we talk about certain viruses, right, or certain bacterias, right, can we naturally make a particular organism immune to it, right? Or can we eliminate a particular disease from the fact that it comes from a gene and you do not have, or you correct that gene itself before even having a birth, right? Can we do that? But obviously, there are two things. How do we understand that this is the gene which is creating a problem? And if even if you know it, how do you take it out, right? Both of the things are problems, right? That is studies understood in biotechnology. Again, this is just an example. The video that I am going to play now is going to have a very important and very useful, example. So you will understand it, right? But biotechnology starts from your smartware, right? Your smartwatch, which tracks your heartbeat, your O2. If you wear I watch, it can also predict if you are going to have an heart attack, if you are stressing yourself much, something of that sort, right? So there are various aspects. There are devices which keeps on reading your blood sugar. There are devices which keeps on reading your blood pressure, right? Again, there are devices which can be utilized for tracking your exercise, right? There are many things, right? And these things are also studied to predict particular symptom for a particular disease as well, right? So there is a huge possibility that if you like biology, or if you like to be in touch of nature, maybe plants, animals, but you still want to be in touch of technology, you can do this with this particular field of it. Very interesting field. I would like to request for the video.
Ever wondered why corn have less worms? Or how a cotton tree produces more fluffy cotton? Let's go back some years ago. Before, when we buy corn, there's an 80% chance that your corn has a worm inside. How did it happen that today's corn don't have worms? It's somehow evolution, but specifically, it's biotechnology. Let's talk about biotechnology. Biotechnology is a science that is based on biology. Every life form is made of DNA, which are the building blocks of every life form. By modifying these building blocks through biotechnology, we can make a corn healthier. At the same time, resistant from bugs and pests. By manipulating these building blocks in another way, we can copy traits of an imported rice that has high threshold in water, then combine it with the local rice so that it can survive in the country. Biotechnology has a lot of advantages in many areas. For instance, in the medical field, we can select the vitamins and minerals we want a certain host plant to acquire. Imagine a life where most of the food you eat are filled with vitamins and minerals. These food can be given to less fortunate people where it can combat malnutrition. Awesome, isn't it? Through biotechnology, there can be healthier food to fight malnutrition in the country. There can be high-yielding crops. High-yielding crops make more income for farmers and helps the agriculture economy flourish. Biotechnology is everywhere. It helps us improve our lives and leads us to a healthier world.
All right. So now we talked about the technologies which are making our future better, right? We talked about AR, VR. We talked about biotechnology, right? Now let's talk about something hardcore, right? Something which is real technology, right? So coming up in front of you is Internet of Things, right? And henceforward, whenever I talk about the technology, I will also explain you how it connects with the next one, right? So when I talk about IoT or Internet of Things, you need to first understand is at initial times only humans used to produce data. So they used to type using computers or typewriters just to produce data, and that was sufficient for us to chat and essentially read, right? The next generation started, smartphones to generate data, and that smartphone was basically able to click photos, have videos, voice, and that revolutionized Web 2.0. But now what is going to happen is you are going to have a new version of technology or web which is called as Web 3.0. We'll not go into depth of it, but one of the relevant technology or relevant framework that you would like to understand about is Web 3.0, right? Now when you talk about Web 3.0, what is going to happen is each and every device, may it be your car, may it be your refrigerator, may it be your speaker, may it be your smartwatch, each and every device would be uniquely sending data that will be interested, that will be interestingly read and understood, right? Not only smartphones, not only humans, but each and every device. Maybe this fan, maybe this LED, right? This LED might be sending data to the manufacturer saying, at this particular weather, this is how I perform, this is how the electricity I burned, this was the temperature, this is how effective I was, right? So anything and everything that you can imagine. So you need to now imagine a world where each device is speaking with another device. Each device is speaking with another device, not only just for speaking purpose. We are not doing chit chat or gossip. No, we are doing this for making decisions. How do we make decision with IoT? We will talk about it in the upcoming video. Please play the video.
Your next refrigerator may know more about your diet than your doctor. How many objects do you have that are connected to the internet? About a decade ago, you probably would have said one or maybe two if you were an early adopter of smartphone technology. But today, I've got a work computer, I've got a personal computer, I've got a tablet, I've got a smartphone, I've got a video game console, I've got a media player, I've got a smart TV, I even have a smart refrigerator. Now, extend this trend outward, and what do we get? Well, it's estimated by 2020 there will be 50 billion objects connected to the internet. Now, that's billion with a B. It's also estimated by the US Census Bureau that there will be 7.6 billion people alive at that time. So that means that for every person, there will be 6.6 objects connected to the internet. We're talking about a world blanketed with billions of sensors. These sensors are taking information from real physical objects that are in the world and uploading it to the internet. It's a world where your environment transforms as you walk through it, because technology that you may not even be aware of is monitoring your every move. It's a world that's constantly changing all around us due to these sensors and the internet, and we call it the Internet of Things. Let's stroll into the living room of the future. Now, immediately, this room identifies you and taps into a cloud-based profile of preferences like climate control, music, lighting, and decor. Had a long day at work? The room knows based on the calendar app on your phone and biosensors that detect the stress via blood pressure and heart rate. So it turns off the rockabilly surf guitar you usually listen to and switches to a more soothing classical music. From environmental sensors outside and maybe even worn within your clothing itself, it knows it was snowing earlier, so the climate control begins to crank up the heat in anticipation as you walk through the door. Now, on the software side, we're talking about algorithms that are so sophisticated, they may be able to predict what you want before you know you even wanted it. So when you walk to the refrigerator, it tells you not only what's in there, it tells you what you can make with the stuff you already have. And it's already telling you what's inside and what's the perfect meal based upon your mood, your activity level, and maybe even, well, your weight loss plan for some of us. As for how many objects could be connected to the internet, well, consider this. The latest version of Internet Protocol, IPv6, creates more potential addresses than there are atoms on the surface of the Earth. So we're going to live in a world completely filled with sensors, with data, reacting to us, changing every moment dependent upon our needs. I'm no longer going to be asking you, hey, what's your favorite color? What's your favorite music? I'm going to ask you, what's your reality like? I know what mine is when I walk into my house, how the world reacts to me, but how does it react to you? This is more than philosophy. It's more than technology. It is altering reality as we know it. And it's all regulated by the Internet of Things.
All right. Couple of things that he spoke about: IPv4 and IPv6. Have you heard about it, guys? Right. So some of you who are into electronics, right, or in fact in IT as well, the networking works on IPv4, right? But it is a schema where you uniquely identify a device in essentially a router or a computer, right? In our terminology, right? But when you have lots of device and you, as I said, you need to uniquely identify each device, you need to understand that this particular IPv4 schema will not run. So Web 3.0, once it is there, right, once it is running in the execution, you will see that the schema will change from IPv4 to IPv6, okay, which will have probably so many combinations as the number of atoms on the level on the surface of Earth. That is what they said, right? So huge combinations. So you can have a particular device and uniquely identify it about the data that it is sending, right? So you need to uniquely identify and connect it to the network, right? So that is possible with IPv6, right? Some of the other thing that they are talking about essentially with IoT is IoT is sensor data with the help of embedded programming getting sent to cloud. Now what happens is you have your sensors sitting along various sites. It is getting the data and putting it in the cloud for processing, right? But here there is a limitation. What if you do not have a network, right? And that is something my next technology is, right? Which is edge computing. Let us play the video.
What is edge computing? Before we define it, let's talk about octopus first, one of the smartest creatures on the earth.
See this.
As invertebrates, they have many neurons, but 60% are distributed on their legs, and the remaining 40% are on their brain. With this distributed computing of multiple cerebellums plus one brains, they are nimble and fast. Just like octopus's distributed computing, edge computing collects data and processes at the edge as well. From PCs to mobiles and other devices like cars, machines, buildings, more and more devices are connected to the internet. The number of connected devices in 2021 will reach the eye-opening 46 billion, which means massive data will be created. According to Statista, the total amount of data created in the world will reach 149 zettabyte in 2024, which means the few cloud centers we have can't handle such massive computing, as every single device sends all the data to them. Low speed, high latency, and even crush can happen a lot without edge computing. So what are the benefits of edge computing? There are many user cases, such as the autonomous vehicle. Just think about the situations like equipment failures and hazardous incidents. They're called for the instantaneous analysis of data. What would happen if the internet is unstable in a remote area? It'll take too long to get the instructions from the cloud back to the car. However, with edge computing, it can process the data locally that is coming in real time with fast speed, low latency, and avoid possible accidents. Since not all of your data is critical and needs to transfer to the cloud, like security cameras that constantly send potential useless data to the cloud, then that's using a lot of data traffic. If the cameras can process the data at the edge, it can help optimize the flow of your data to reduce the cost of the data that connects all of your devices. If all of your data must eventually send to one cloud through the public internet, your network security can be highly vulnerable. As the more data transfer, the easier they can be intercepted. When you distribute data by edge computing, you distribute the risk as well. What about privacy? As less data is uploaded to the cloud, you will have more control over your personal data. Imagine if your Google Home speaker could respond to your weather forecast requests without sending data to Google's server. Then they would have less personal information of you. Even though these companies are unlikely to give up collecting our information, but with edge computing, we at least have more freedom to choose. Thanks for watching. Make sure to subscribe InHand Network's YouTube channel right now. Just click on the subscribe button right here.
Okay. So the example they have given is of octopus. Now octopus is having 60% of the neurons in his tentacles. So he is not processing the information, whatever he is sensing, by sending it to the brain, like what we do, right? It happens right in there in the tentacles itself. Isn't it smart, right? So I feel like octopus is just like an alien, it's so smart, all right? So the idea is when you have this octopus, mimicking this particular methodology, right? That you process the things on the edge itself, where you are meeting the data. Why can't we do it? So in case of network failures, in case of slow speed, right? In case of low latency, what was happening was you were processing it at the edge. You are doing it at the edge, right? And very similarly, what edge computing is doing, it is doing the same thing. It is trying to take the data and the control in hand and trying to take the decision itself on the fly in the real time. Okay, that's the edge computing. But then while we were seeing this video, we also understood that speed is also a problem. Do we have networks which are which are seamless, which are speedy enough to support that huge data transfer? Because now you have huge number of sensors. Even if we talk about today's cars, we have tire pressure monitoring system, CPU monitoring system, various alerts. We have an entire alerts that comes through the car network. There are huge things that is coming nowadays, right? And when we talk about connected cars, when we talk about other technologies, right, this huge data, for us to pass it on the cloud, we need bandwidth, we need less latency, more performance, right? Now, cut to 3 years, 4 years back, we were not even able to see the video in one go, right, in YouTube. But now we can, post Geo, right? So post we introduced 4G, 5G, the network started spanning. Here we have this technology 5G, right? Let us play the video. You can read the slogan, seamless connectivity, limitless possibilities. So with IoT and 5G and edge computing, you have limitless possibilities. That is what I am trying to say. This is how you look at it. Only 5G will not ever help you. Okay? Only IoT will, help you, but not to an extent. But when you have a combination of 5G plus IoT and edge computing, you can develop a system which is very robust and seamless. Okay, let's see the video.
5G is the fifth generation of wireless. To understand it, you need to understand where it all began. First generation wireless networks got us started with phone calls. Soon came text messaging and eventually the mobile web. Then 4G got us video chatting, ride sharing, social networking, and using apps for just about everything. Like the generations that came before, 5G will change our lives in all sorts of unexpected ways. The first 5G networks are live across the country, and they'll continue to improve the coming years, becoming up to 100 times faster than today's 4G networks, putting high-speed broadband in the palm of your hand and allowing you to stream picture-perfect 4K video and download whatever you want, whenever you want, instantly. But faster speeds are just the start, because 5G will be 5 times more responsive than today's networks and will connect 100 times more devices. That means phones won't be the only smart wireless devices. 5G will connect us to our world in new and innovative ways, from driverless cars that communicate with each other to avoid accidents, to roads, buildings, bridges, and pipes telling us when they need repairs. Augmented reality applications that create new learning experiences, and new healthcare models such as patient monitoring and remote surgery. We're only just beginning to imagine the possibilities. That's 5G, coming to everything near you.
Thanks. There is a use case that they are discussing, right? The operation use case. The doctor was showing how the bone can be corrected, can be operated, and you can now imagine AR, VR also coming into picture, right? So for AR, VR also, huge data would go, images, audio, video, right? Your surrounding, anything that is around you and anything that is coming from the cloud, right? Obviously, what you require is speed, right? So this is very important. Imagine somebody is operating and the network goes off, right? So it's a problem, right? So that's 5G. Now we have cyber security, right? So imagine this. The next two technologies is going to talk about security, right? We are enhancing in each and every direction. We are talking about AR, VR, we are talking about 5G, lots of devices, lots of computers, lots of computing power. Who is taking care of our security, right? We are not safe today, right? The banking transactions are hacked. There is, there are viruses. There are incidences where personal identities theft, right? That are happening. Cyber security will ensure that when all of this is growing, we are entrusting our, we are rebuilding our trust in the progress that is happening, So that's cyber security. Let us have a look at it.
What is cybersecurity? Cybersecurity is the practice of protecting systems, networks, and programs from digital attacks. This has been fueled by the explosive growth of the internet, with 3.4 billion users, which has become a haven for hackers. Cybercrime has quickly become a top-level security priority across the globe. This has created a huge demand for cybersecurity experts. This is why learning about cybersecurity is more important than ever to develop secure software, identify and respond to cyber threats, and critically analyse digital evidence to solve and prevent crimes. Cybersecurity can open up many different career pathways. For example, ethical hackers are useful in testing the system's security, while a cyber forensic investigator works with law enforcement to retrieve data or find digital evidence. We are more reliant on technology than ever, and cybersecurity plays an integral part in every device we use. Play your part in securing our digital future. Learn more about our cybersecurity and forensics course at Murdoch today.
That was cyber security. Next screen, please. Next technology. Blockchain. Again, we'll talk about that. Once we see the video, I'll talk about both cyber security and blockchain at once. Okay, please play the video.
Modern technology allows people to communicate directly. Voice and video calls, emails, pictures, and instant messages travel directly from A to B, maintaining trust between individuals no matter how far apart they are. When it comes to money, people have to trust a third party to be able to complete a transaction. Blockchain technology is challenging the status quo in a radical way. By using math and cryptography, blockchain provides an open, decentralized database of any transaction involving value, money, goods, property, work, or even votes, creating a record whose authenticity can be verified by the entire community. The future global economy will move towards one of distributed property and trust, where anyone with access to the internet can get involved in blockchain-based transactions, and third-party trust organizations may no longer be necessary. The uses of blockchain technology are endless. Some expect that in less than 10 years it will be used to collect taxes. It will make it easier for immigrants to send money back to countries where access to financial institutions is limited. Financial fraud will be significantly reduced, as every transaction will be recorded on a public and distributed ledger, which will be accessible by anyone who has an internet connection. Think of it as wills and contracts that execute themselves, or dated proof of existence for ideas, much like a patent. Blockchain will become a global, decentralized source of trust, but not everyone is ready to embrace it. A huge proportion of trust services, from banking to notaries, will face challenges on price, volume, and in some cases, their very survival. Public authorities could find it more and more difficult to enforce traditional financial regulations due to the new possibilities offered by the Bitcoin network to bypass traditional financial intermediaries. Unimagined new networks will evolve to meet society's needs more cheaply and potentially more securely. Will governments, financial and legal institutions embrace blockchain? What will happen to the ones who don't?
Okay. So simplest way to to understand blockchain is to ask you a question. How many of you have seen there is a web series called as Scam 2003? That person, right? सबसे पहले हाथ ऊपर किया उसने. All right. देखा है, right? तो उसमें what are they faking? What were they faking? Huh? Stamp papers, right? Now why do we use stamp papers, guys? Anything that we need to register on our own name, anything that carries values, anything that we need to pay back to the government as an revenue, right? As a revenue tax, right? Anything that holds an identity. Right now, all such things are centralized. What was the slogan? It was open distributed database, right? So what does it mean? If you have a particular stamp paper, which is, let's say, digital in nature, it is not centralized, it is not kept on a server. It is spread across the whole internet, and it has all the copies spread across, right? And now if you want to read it, you would be very easily be able to do that. But if you want to modify it, you will be required to change the most, you will have to require to change the quorum. Quorum is, if you have 5 such copies, you will at least have to change 3, right? Majority, right? And you have lakhs and millions and billions records spread across everywhere, so it is decentralized, right? Now tell me guys, will you be able to fake a particular document? Yes or no? Will it be possible to access the whole network, change one document because you want to name yourself from Dheeraj to, let's say, Raj something? I cannot fake myself, right? I cannot do that, right? Getting me? So blockchain is a way to do that. Blockchain allows you to store data in a decentralized manner, in a way that it is very difficult for someone to change or fake, but it is on the contrary very easy to access. Okay, that's blockchain for you. Understood guys? Yes or no? Nahi, sab so gaye. Yes or no guys? All right. Okay. Now sabka favorite machine learning, right? Let's see the video.
As technology evolves and the world's population grows, so does the amount of data being generated. Collecting, sorting, and analyzing all of this data can be pretty time-consuming. However, that's starting to change with the emergence of something called machine learning. Machine learning is a type of computer science that allows computer programs to learn and improve all on their own. In the past, computers could only do what we programmed them to do. But with machine learning, they can behave like humans and gain knowledge based on their past experiences. This process can get pretty complicated, but here's how it works on a basic level. Let's say we want a program that can tell the difference between apples and bananas. First, we'll give it some labeled pictures of each. The program will then look for patterns in the fruits and start to remember them. It can then use these memories to look at unlabeled pictures of apples and bananas and determine which is which, all on its own. Believe it or not, you probably encounter machine learning on a daily basis. Social media sites use it to create your feed based on your preferences, and search engines use it to improve the accuracy of their search results. It's also being used on a larger scale. The medical industry is applying machine learning to things like predicting lifespans, organizing patient data, and even diagnosing certain diseases. As with many emerging technologies, there's a concern that machine learning may eliminate certain jobs. This will vary from industry to industry, but it does have the potential to get rid of or change a number of occupations, including drivers, bankers, and potentially even certain doctors. While it may have some negative effects, many believe that its positive applications will outweigh them.
Goodwill Community Foundation, creating opportunities for a better life.
So machine learning, we can summarize machine learning with, very few keywords, right? What are they? Pattern matching, okay? Pattern matching, model, and then the decisions, right? So how do we look at the patterns? How do we match the pattern? For looking at the patterns, how we train that model? And once that model is trained in a supervised or unsupervised manner, you would then put a question to it which will give a decision. Numerous applications for machine learnings, for autonomous cars, to vision system that will help the blind people to navigate. Right now also they can navigate, but think about an algorithm that tells them how many steps to take, what he is looking at. So there is a huge crowd sitting, there is a way, so there are models which will understand the image and then announce it, right? That also is possible with ML. ML has huge possibilities from recommendation. So if you are watching Netflix or Amazon Prime, the recommendations are coming from Netflix. So it is learning from us, and with the help of the learnings that it is taking from us, it is applying it to us, right? And a very blur line always between ML and AI, but AI is basically artificial intelligence, and it is broken down into two major areas. A general artificial intelligence and a specific artificial intelligence. We are moving ahead from a specific intelligence towards general one, where like what intelligence humans have, right? We are able to do each and everything. So let's talk about artificial intelligence for a machine which is able to understand the situation and navigate from a path, but it will be able to do it that in a restricted manner. That is the only thing that it will do. It will not be able to talk or sense or walk like us, right? But we will be able to do that. So there is a still lots of research, lots of work has to be done in a general AI area, right? But specific AI, yes, there is a lot of work done. Let's see the video. Okay, please.
When you hear the term artificial intelligence, what comes to mind? Superpowered robots? Hyperintelligent devices? Science fiction has familiarized the world with the concept, but outside of Hollywood, what is artificial intelligence and what can AI actually do? For starters, AI involves using computers to do things that usually require human intelligence. Humans can see with their eyes and process what they see. We can understand our environments and move around within them. Our brains have the ability to see patterns, and we have the ability to understand spoken language. Artificial intelligence is a broad branch of computer science that includes many different terms. In order for computers to achieve these capabilities, they require lots and lots of data. Large data sets allow AI algorithms to identify patterns, make predictions, and recommend actions. Artificial intelligence is already all around us, but today's best AI still can't compete with the human brain in some ways. For example, in 2016, the computer program AlphaGo defeated a legendary professional Go player. But if you asked that same computer to drive a car, or walk, or even play Monopoly, it wouldn't be able to do so on its own. AI's computing power is massive, but our human brains are able to tackle a much wider set of data and methods.
Right. And those who thought, that was the last video, it is not, because we are from software background, we have zeros as well, right? All right. So, this is the last one, generative AI. But let me tell you what generative AI is in a simple word or simple understanding, right? So, like humans, guys, pay attention, guys. Yeah. So, in simple word, when AI is specifically doing a particular activity, but like we humans, right? Can it paint, right? Or can it create a video? Can it create a voice? No, right? So generative AI is a specialized AI which is now mimicking humans by learning various patterns with various models, and is trying to cover up a area where we are generating certain things. So it can be a text, audio, video, right? And this is done in such a way that, let's say, if I want a particular song to be sung in a Mohammad Rafi's voice, right? So let's say Sudesh Bhosle I would call, and he would mimic that. My generative AI be my Sudesh Bhosle now, because he would understand that pattern, and he will take that input, understand so many songs sung by Mohammad Rafi, and then take an input of a new song, and then he would recreate that new song in Mohammad Rafi's voice. And those who are active on Instagram, they must have seen it as well, right? So it is nowadays possible. There are deep fakes. A particular body or a particular model is completely created from imagination, right? By creating, giving more inputs, right? So all this is possible. You can have imaginary text given, and that can be converted to a video or a audio, or a script can be converted to a video like you are recording. But it is nothing in actual. Everything is computed based upon the AI, right? So that is generative AI. Let's play the video.
What is generative artificial intelligence or generative AI? Generative AI is an artificial intelligence technology that can create new content in text, image, music, and video forms. Businesses are exceptionally excited by the possibilities of specialized generative AI models because they can be trained on an organization's own corporate data. And they can collaborate with knowledge workers to dramatically boost productivity. Estimates value the productivity boost at up to $8 trillion a year to the global economy. An example of generative AI is chatbots, which have taken the world by storm, thanks to their ability to write human-like conversational text. They can express complex ideas synthesized from the vast volumes of information on which they are trained. In business, they can help write or improve emails and presentations, help ideate new marketing campaigns, and much more. Generative AI relies on machine learning models that mimic human neural networks, a concept that dates back to early AI research. Critical algorithms emerged in the 1980s that advanced the science, and in the last few years, new training algorithms. The availability of purpose-built processing units, for example GPUs, which provide massively parallel processing power, and refinements in training datasets. These have all led to the systems that we use today. The result is generative AI models that appear to create surprisingly like humans do. Innovation in generative AI is accelerating at breathtakingly fast speed as businesses all over the world experiment with it, while entrepreneurs and investors launch new business ideas to build upon it. Generative AI has launched a new era in technology that promises both greater productivity and new ways to solve business problems that simply weren't previously possible.
Awesome. So thank you guys. I hope you liked this. Thank you. I just have one request. I wanted to have a selfie with you guys, okay? Right? That's fine, guys. Can I have a selfie with you?
Students, if you are having any query, you can ask the questions. Anybody is having any questions, you're welcome. Thank you, sir. It was excellent session on recent trends in computer science and engineering, quantum computing, AR, VR, biotechnology, IoT, edge computing, 5G, cyber security, blockchain, machine learning, AI, and generative AI. It will be definitely useful for our students in their academics. Now, we are honored to have with us Dr. Rajkumar Bhuiya, a Redmond Barry Distinguished Professor at the University of Melbourne, Australia. Sir also served as the Director of Cloud Computing and Distributed System Laboratory. As the founding CEO of Manjera Soft University spin-off, he commercialized cloud computing innovations with over 850 publications and 7 textbooks. Including Mastering Cloud Computing, Dr. Bhuiya is highly cited in computer science recognized. As a Web of Science highly cited researcher 7 times, he has received a global accolades including Best of the World distinctions. Under the leadership, technologies for cloud computing have gained rapid acceptance in 50 plus countries. His Aneka Cloud technology received a first New Product Innovation Award, and his influence speaker, he has delivered over 700 talks and recently become a fellow of the Academy of Europe. I request Dr. Bhuiya to lead us with this session.
Good evening. I guess all of you are waiting for possibly catching a bus. So let me give you a different spin for all the top technology trends that we discussed so far by our colleague. So he mentioned about 10 of those. So now, can we make can we make that happen in India? So the governments talk about make in India. And here is the vision, the big promise that is being made through various videos. They should not remain as a video. You should develop real product, real solution that makes difference to India. And of course, the country is looking forward itself to make India as a developed country. You don't have to go to America to create product and solutions. You be here and create and make India great and make India as a creative power. And how can we do that? And of course, there comes skills. And skills means someone who has done a research, foundation research, and created a knowledge. You can take that knowledge and create real technology or real solutions. Let me briefly touch on, morning we already discussed about all of this. So first, skills. So for students, where do you get skills from? So obviously skills from books written by some people. And here are some of the books I happened to co-author when I was just graduated from engineering. So for example, here is the Mastering Cloud Computing book. Okay, so we will talk briefly about skills needed to create those solutions. The first set of skills are something you learn from the books. And where are these books comes from? These books comes from people who do foundation research and they see the future and write those books. So here are some books, for example, to program, to be able to program efficient communication from one device to other device. How do you write those programs? Most of them are written using microcodes and assembly language. And if you want to learn assembly programming and then develop 6G, not just 5G, 6G network, you need to learn, for example, how to program them using microprocessor level and assembly language programming. This is something I would encourage. Next, you want to write those applications. You want to use high-level programming languages. Say, for example, C++. So here is a book. So I'm not sure how many have seen the C++ programming. Then he talked about massive scale computers. They are called data centers. How to build those data centers. And I have put together a book that was in 1997. How many of you are born in 1997? So this is a book available. You can go through and read about it. And if you do not know English, don't worry. If you are coming from Nagaland, knows Chinese, you can read that book, same thing in Chinese also. Okay? Then of course, our colleague talked about cloud computing. You want to master cloud computing. So here is a book called Mastering Cloud Computing, both in American edition and also Indian edition and Chinese edition. Then our colleagues talked about big data. What is big data? Massive amount of data is collected and the data need to be organized, data need to be categorized, data need to be processed. And what are the skills to do that? And here is a big data computing. And our colleague talked about Internet of Things. What is Internet of Things? The sensors that are able to communicate. These sensors, not only the computer network communicate, but also other things, so the camera able to communicate, fridge is able to communicate. So those become Internet of Things. If you want to learn the foundation and build those, and there is also a book on Internet of Things as well. So this is edge computing he talked about. Then this is Internet of Things. Okay. Then move forward. We talked about quantum computing. So just wait for a few months, you will get a quantum computer book from me. Okay. So that is about skills. And then I want to highlight how is that these books come up. You know, cloud computing today we talk so much. So the research for cloud computing has happened all over the world. And of course, one of our laboratory, which is Cloud Computing Distributed System Lab at University of Melbourne, has developed many foundation technologies, foundation ideas, and they have become underpinning technology and the source for the emergence of this field of cloud computing. So many of the cloud solutions that you see today, the underlying technology is the patent that we have got and licensed to many IT companies. And I wish I had a more time to discuss with you how to create a technology of your own, not just think about the promise, but also how do you make that promise reality. Okay, with that, since I don't have time, just to briefly, you all know that all the waves of computing happened and happening. By 2030, hopefully, you will have a quantum computer available to you. But before that, you want to create the idea, you want to create solutions. We do have effort in that area. Then moving forward, you see all this technology. What is the driver? Either a scientific application driver or some military application driver. But today, the driver is the big population. The country being, India, with large population, can you create a healthcare solution that unites IoT, sensing, analytics together? So how do we do that? So let me illustrate as we go along. When we say data-driven world, so there are many applications of data-driven world. Applications in the scientific community. For example, maintenance of mechanical systems. So that is a data-driven system. Then of course, healthcare we talked about, data-driven system. Then we talk about Internet of Things. Things that generate lots of data. So to be able to analyze in real time. So action. So these are our, solutions. And there are a lot about cloud computing mentioned. What it is actually is something, a service you can rent as a paid computing services. So you don't have to buy computing hardware infrastructure. You can rent it, use it, and pay for what you use it. So with this, you have many applications that are there. And these cloud services that we talk about, you can give it to people in the form of infrastructure, in the form of platform, in the form of application service. This is the third one, is something most people talk about. So how do we make these services available to users? And then in terms of delivering it to users, there are three ways. The first one is what we call public cloud, and the second one what we call private cloud, and the third is called a hybrid cloud. So these were multi-cloud to be able to combine distributed capabilities. Our colleagues have mentioned, if it is in a centralized, somebody can break it. But if it is decentralized, distributed, then it is difficult to break. So this is where multi-cloud computing comes into picture. And of course, there are many applications. I want to highlight one technology that we created. We discussed a lot in depth in morning, but I just want to give you a brief view. So here is a technology called Aneka, first developed in 2006, first version. Okay, before cloud computing came into picture. I want to highlight, student like you can be very enterprising. You create a future. You don't need to know about these future emerging technologies. You create a future. So therefore, people talk about you, correct? So earlier we talked about others. What is happening in America? Technology 1, technology 3. Next, in the future, if somebody speak, oh, here is a student from the St. Vincent College. He did something interesting, and that is the future. Okay, so this is all possible. Then I am the proof of that. So, for example, this Aneka technology is a cloud application platform that you can use to build all those applications you're talking about. In cloud computing environment, millions of users are using it. How do you build it? To be able to scalable. So Aneka helps you to build such application. Then you can deploy in a private or public or a seamless manner. And in terms of how does it actually works? A simple image processing they talk about. How does it work internally? Internally, you have this kind of input images and videos. Those will be broken into many small pieces. And then it is given to cloud system specifying this is my response requirement. So the system dynamically provisions resources. Then of course, then move the computation there and processes all the computation in different places. Then finally it brings back results to the one who created an application. Then after that, that application image or a video is identified, and then of course you turn this into for example, emboss. And then after that, all the resources allocated are released. So this is called cost-efficient allocation of resource. So this is in reality. And this technology is used by many people, but let me highlight one from, say, for example, China. How are they using it? In China is well known for creating high-speed trains. Why can't we do in India? If I want to come from Bombay to Nagpur, can I come in 2 hours? Not possible today. But if you have a train like this that are there in China, it's possible. And they are using this technology. So here is the train design scenario. And they are doing this scenario analysis using 4-core server. that was taking 20, like 4 days. And to reduce that time, they set up a private cloud using our technology. And then we have a tool called Design Explorer. As a result, what took 80 hours, they are able to do it in 2 hours. So this is a creation. We create a technology that other people can use it. That was in China. What about India? India is well known for satellites. They're launching satellites to moon, satellites to sun. So what are you doing there? So you need to be able to analyze that images that are coming from there, develop some insights, and this is what ISRO is doing using our technology. So here the ISRO, satellite data coming in and bringing and storing in the local storage cloud, and they build an application which can be used for analyzing. So what is there in the moon? Is there a water? Is there a mineral? Is there a gold? Is there a diamond? Otherwise, what is the use of going there? So analyzing that kind of data, processing images is interesting. The next, all of you have got mobile phones, right? Anyone doesn't have a mobile phone? Everyone has a mobile phone. But the problem with mobile phone is the battery gets depleted too quickly. If you run an application on a mobile phone, so your battery power will reduces very quickly. What can we do? We can outsource mobile computation to the cloud. And here's an example of an Aneka toolkit used to create a mobile application, and that toolkit outsource computation to the cloud where actual processing is done, then finally results come back. By doing this, what can we do? We are able to increase the experience of the mobile phone and also get bigger things done in a cloud and visible in the mobile phone. So like this, there are few applications. In the interest of time, I am skipping. If you want to learn more about yourself, want to explore yourself, please visit mandrasub.com. This is a website from where you can download the software. So right now we have Aneka 5.0 online. Soon you will get 6.0 version. So software, download and learn yourself. So many students in India have been able to do many interesting work and publish paper. Some are able to come out with market product and they are selling in the world. So that is what I want you to be. You just don't be happy with viewing that video. You need to be able to turn that into reality. And all this can be made possible here. And of course, many other peers throughout the country, they have learned cloud application programming. How many of you can do application programming of cloud computing? No one. Very important that you go tomorrow or today, go to our website, download this software, learn how to do this programming. Then you will be in real action. Okay, so many are doing it. Then this IoT talked about. So let me give you a glimpse of IoT applications are many that was mentioned in the video. So there are many smart homes, smart car, smart manufacturing and so on. But to program them, the problem is if many IoTs are pushed to cloud, you have a problem. Therefore, you use the edge computing resource. But how do I do that? Here is a real technology we built called FogBus. It's a lightweight frameworks for edge computing that comes with blockchain. Blockchain was mentioned about. So we can embed blockchain into this framework which is already there. So this way you can provide trustable services, trustable cloud services, trustable healthcare services. So it's very simple. Here is IoT device and here is an app running on a mobile phone. And here is our framework called FogBus Master. When you send it to the master, master is able to process on different edge resources, edge compute resource through Raspberry Pi, and then you compute on the public cloud if necessary. And we put together application. So application for healthcare, Healthkeeper. So this is a device, send it to mobile phone called Healthkeeper app, and then that does the processing. This is for sleep apnea analysis. So by analyzing this data, it is able to tell whether a person's sleep apnea problem, is it normal or emergency and so on. So this is a real healthcare application that we put together and demonstrated. You can see this is the device and process on the cloud and the results come back. So I would like you to just take this FogBus software and build one yourself. Then coming to quantum computing. Quantum computing is no more in the video. Even the Modi is talking about it. Okay? For Modi's third term, he promised to put 6,000 billion crores of rupees for quantum computing. And you should think about how can I turn Modi's dream into reality. He's only dreaming about it. But someone has to do the work. Someone has to build the solution. Someone has to bring it to the marketplace. And for that purpose, let me give you just two quick solutions. One called iQuantum Simulator, other is a practical system. This is no more theory. Of course, it's theory for some people, but it's already a perfect ground for research. And one of them called Quantum Framework. So programming quantum computing is very difficult. That was already told in the video. But here is something we make it easy. So this is a software we developed wherein you build your application that made up of functions. the standard function and quantum function. If it is a quantum function, run on a quantum emulator, otherwise run it on a real hardware. So that is how you can do it. But if this is too hard, don't worry. We have a simulator also. You can simulate a future quantum. So right now quantum only 62 bits, quantum qubit, correct? But you want to create a quantum of 1 million. Where is it available? Not available. So therefore you can create a model, you can simulate. So this is a simulator for quantum computing, where you can simulate quantum processor, you can simulate quantum task, then you can simulate a cloud environment and then make it part of the cloud environment. Then you can do your research on the future prototyping. And once your prototyping is good, then you can do real system. So like this you can actually create. And of course I would have discussed about how to do that research, but because we don't have time, so in interest of time, let me briefly talk about what are the skills that you need. Now we heard about all of that. In reality, you need to be very good in programming. This is very, very important. All of those that talked about, unless you are very good in programming, it is just simply a dream. Correct? You see some dreams in night time and you get frightened. That's all it is. But if you want to turn the dream into reality, make sure that you are very good in programming. Make sure that you are very good in database programming. Make sure that you know what is real AI, what is the algorithm to be able to do it. Then of course, have some practical experience, that will be good. So that is about skills. But if you learn these skills, what can you be? Some titles of jobs. For example, your colleagues asked me to talk about. You can become, for example, architect of those systems. Can be cloud architect or edge architect, whatever architect. Then you can be a software engineer, or you can be a, for example, scientist. The scientists play a foundation role in emergence of all this technology. So the market talks about all the big things in a very glorious video form. But to do that, foundation research has to be performed. And you can be one of those, the one who create the future. Correct? You create the future, people talk about it. So that is something scientist. Or you can be some kind of network security analyst or cloud security analyst. There are lots of positions, and accordingly the salary will also change. Correct? Maybe sometimes salary will increase. If this is $150K, then this might be 70K. Correct? So like this you can vary. Anyway, it doesn't matter. If you are passionate about something, you do it. Okay. So with this, let me stop here. And of course, there are books, as I told you. I'll skip it here. And I'm just keeping the list of books and enjoy. Yeah, I was given 15 minutes. I hope I did some justice within 15 minutes. But since I have saved some time, you can ask some 2-3 questions. Can you please give the mic to anybody who wants to ask a question? Quick, run. Yeah, please raise a question. Raise your hand and ask a question. He will give you a mic. You can ask me a question on the previous speaker or mine also. Both are okay. Everyone is looking at others' face, as if the question is on others' face. Yeah? So no one has a question? Everyone has understood? How many of you understood? Just raise your hand. Let's see. Only few. Then ask a question. Okay, good. Sometimes you have got the problem of ambassador car. In ambassador car, unless someone push it, it won't start at all. Correct? Somebody has to push to ask you a question. Okay, if there are no questions, so just search these books, explore yourself. If there are any questions, later you can email me. I will try to answer. Thank you very much.
Thank you, sir, for session on cloud computing and the career in the cloud computing. The session is very much helpful for the student that they will be improve their academic with this referral of this book. Now I take this opportunity to propose vote of thanks. I would like to thank Professor Rajkumar Bhuiya sir. In spite of his busy schedule, sir has visited our campus and shared his valuable time with us. I would like to thank Mr. Dheeraj Modghare sir for sharing valuable knowledge with us. Thank you so much, sir. I would like to thank management for organizing the event for the students for improving their academics. I would like to thank heads of various department, faculty in charges, and the student for patient listening. Here I conclude the session. Now everyone kindly rise for national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Students can collect their refreshment before leaving.